Hello guys, my name is Ricardo, and today I'm going to show you how to deploy Kogito workflows on OpenShift, and to explain everything that is going on over there, how we go from a serverless workflow file to a microservice deployed on OpenShift using Kogito, right? Well, for that we use the serverless CNCF serverless workflow specification project. That is a specification to declare workflow models in a workspace event-driven serverless applications. So you can use the specification to define your workflow and to use that workflow to build your microservice using Cogito. The project is a CNCF sandbox project, and we are looking for contributions. And at the end of the video, I will show you guys how to engage with the documentation and see more about the specification itself. And for that, of course, this is the key channel, and we are going to use the Cogito uh, platform to build this service using the based on the service workflow specification. That is, if you don't know what Cogito is, it is basically a cloud native business automation platform. You can use that this platform's framework to build your business application, like using process rules and all of that domain driven and cloud native focused. Wait, I will not extend too much explaining what Cogito is. For that, we have other videos explaining all everything. I will link them in the description of the video. So let's try to simplify our workflow using this equation. Okay, because equation is a flow, right? To solve this problem, for instance, we have to subtract a value from one, and then we have to multiply for others. So it is a flow. It is a step by step flow. So the first thing you subtract, and then you multiply. So this is the equation to convert a given temperature, a given Fahrenheit temperature to Celsius. And let's say, let's use this use case to implement a workflow and deploy that super microservice on the cloud, and how we could manage to do that. So imagine that this is a temperature conversion workflow. They have to call the subtraction service and the multiplication service. The subtraction service, we do just that. You subtract values, and then the multiplication service does that, like that, multiply services. So we call subtraction service, and with the result of the subtraction service, we call the multiplication service. Let's go to the code. But for that, all the resources is linked on the video description. I will also share this all these resources with you, everything that you need to know to deploy this service, and to know what's going on will be just on the video description. Okay, so let's go there. Uh, the first thing that when we start thinking about workflows and business application in general, the smarter thing to do is just try to understand our problem. So in this example, our problem is to convert a given temperature in Fahrenheit to Celsius. So we know that we have this equation, and we can use Fahrenheit minus 32 times 0.5556. This is our business problem. We need to convert Fahrenheit to Celsius. And in terms of serverless workflow specification, use the specification to describe our workflow. We use state diagrams, right? Uh, and let's think a little bit about that. When we start our state diagram, the first state is the inject state that I'm going to use from the serverless workflow. This inject state, it is basically telling us that we are going to inject uh, some variables to the context of the workflow. So the first thing is to know the constants in our equation. The first constant is the subtraction constants, that is 32, and the second one is multiplication, that is 0.5556. So in the first state, first I will inject those values, these constants values, to be used later on my workflow. And then I transition to the next state, the operation state, as they are defined in the serverless workflow. And the operation state, it is a state that we can define actions and the sequences of actions that we like to perform. And I'd like to subtract and I'd like to multiply, right? Because that's the thing that we are doing here. First step, we subtract. Second step, we multiply. So we call the subtraction function, and we call the multiplication function. And then the result of this sequence of actions, it is our given Celsius temperature. All right. So now let's try to instantiate this problem. Try to understand this problem with real. Try to mock up this real use case by starting inserting a value in this workflow, that is 100 Fahrenheit. So when I start this workflow, I will have Fahrenheit defined as 100, and we will have subtraction of constant defined at 32, and multiplication defined as that number. All right, that's the role of the inject state. In the next step, the operation state will use those values to call the subtraction function. I use f, and I will use s, and the difference is the new variable that we got, that we are going to get after calling the subtraction value. And I'm going to call the multiplication value with this the difference, that is the result of subtraction, and the constant multiplication to this function. And the result of that is the my converted Celsius temperature, and I can finish my workflow. So the thought process is pretty simple, but it is just like that. We perform the steps, and we try to understand how we manage to declare our workflow. By doing that, we get to the serverless workflow definition files. You can use JSON or YAML files to describe your workflow. In this case, I'm using JSON. We have some metadata information in here, like ID, name, version. All those information is used by the Kogito runtime to generate some code for you after to declare your workflow. So, for instance, we are going to use ID to name your microservices or microservice on OpenShift, on cloud, or on the generated application itself. And we have the functions definitions in here. For Cogito, you have on the name that we call multiplication, the resource, that is the path where my service is. It is in the root path for this case. The type of my function is REST, and I'm going to use the method post to call this service. The same thing for subtraction. So I declare my functions in the workflow definition for future use on my states definitions. So the first state is the inject state, like we saw in the board. We start saying that we would like to start this is the first state, the start state, and we're going to name that set constants, and it is basically setting the information 32 and 0556 to those attributes here in the context of my workflow. That means that those two attributes will be added to my workflow context. And then next, I said to my workflow that I'd like to transition to the next state that I call computation. That is the next state, computation. It is a type operation, sequential, type of operation, and I'm gonna call those two actions. The first action is the subtract, and then to multiply. I'm referring here the function that is subtraction that we define here above, and I'm going to say the left element and the right element of the subtraction microservice is Fahrenheit for left element, and subtract value, that is the constant defined here, for the right element. Same thing for multiply, but in this case we're going to use the output of the subtraction function as an input for the multiplication function. And also I'm going to send the constant as multiply value. And the result of this function call, it is my Celsius being converted, Fahrenheit temperature converted to Celsius. So this is the end of my workflow. So this is a Maven project defined as with the Kogito archetype. So as you can see here, you can use this command to generate this project for you. It is basically a skeleton of a project. You can see more about more information about this and how to generate your Kogito project in our documentation in here that I will link for you guys as well. Okay. Well, in this project, I basically have my resources directory, the workflow file, and I have other important file that is the application properties. So this is the properties of my application in here. And we have this special configuration that is prefixed by Kogito SW functions, the name of my function as I define in my workflow. And I add host and port to this function, meaning that my service is located at this host, at this port, same for multiplication and subtraction. So during runtime, the Kogito engine will call these services using this information that I put in here. Also, the another important file is the POM XML file that is generated for you. We don't need to worry about that or create or anything like that. You can, of course, edit things like the description here. Instead of generated project, you can name it as you please. And the only dependency that we need to add manually is the Kogito REST work item. That is a work item that we are going to use to call the REST functions using this serverless workflow file. So this is basically this. Nothing else. You have the POM XML, your serverless workflow file, and the application properties. And we're going to generate code for you to transform that into a microservice. As you can see here, target directory, you have the process that is the Java class that represents your workflow being generated for you based on the declarations that you have in here. So you don't have to know Java to to create your workflow. You just declare that, generate code, and that's it. And you can compile as a jar file and use that jar file as you please. In this case, we're going to deploy that on OpenShift. All right. So we have our OpenShift here. Let me open the console. So you can see the topology of the services, everything that we are running in there. Let's wait a little bit more. Okay. So the first thing that we have is a Nexus server that is basically a Maven cache service. So I'm using that to cache all the libraries that I need to to build my Kogito service, my Kogito workflow service. So instead of going to the internet and downloading everything every time that I have to build the service, I have to deploy the service, I just use this near cache. So the build is super fast because of that. And also we have here the Kogito operator deployment that is will be responsible to create all the build configurations. There's this the source to image build configuration on OpenShift for you, and also to deploy the service and manage the configuration and everything that you need for your service to be deployed on OpenShift. And also we have installed the OpenShift serverless platform on this cluster, And these two services here, the subtraction service and the multiplication service, those are two Quarkus applications that deployed as native to be, since they scale to zero, so we don't have pods for those yet. Let's show to you what kind of pods that we have. We just have the Kogito operator and the Nexus instance running on this namespace. We don't have the subtraction and multiplication pods up and running. That's a cool thing about serverless. You don't need if I don't the service, I don't need to scale that. Um, to deploy the service on OpenShift, you're going to use our Kogito CLI tool. That is a tool that we offered within the platform as the Kogito operator, our Maven archetypes, and everything that we need to deploy and create your business applications. We have the Kogito CLI as well. And I'm going to deploy the service in here. It is basically what I'm telling to the CLI is that I wish to deploy this conversion flow service. This is a name of the service that I wish to add, and I'm gonna send everything that I have on this directory. And the CLI is smart enough to understand that we have a POM file in the root path, and this is a Java Kogito project. So I'm going to upload all those source files to OpenShift to start my build process. And also, I've added the Maven URL instead of going to the internet and download everything every time. Just use this Nexus server for you. So I just call it. All the files are packed and triggered. So what I have here is my, since I have everything deployed locally. I have everything running locally. The CLI will deploy everything. So let's clean this target directory first, so we won't have to deploy everything every time. And let's delete the project because I made a mistake. I had all the target files generated in my directory. And for this example, I'd like to show you guys how our process actually build the service in there on OpenShift instead of building locally and push the jar files to OpenShift. We can do both. The CLI understands both, but takes precedence for the target directory. If I have the target directory in there with all the Java compiler and everything else, the CLI will use that. But instead, I'm going to just deploy the source files instead. So as you can see, all the files from my project will be used in this case. And in here, we can describe the build. Let me see here. Yeah, that's the one. Let me clean up this. We can see like what is going on in the build stage for the CLI. So when I call this CLI command, I'm telling to OpenShift, hey, use these files to build my service. So the operator will take all those files. The Kogito operator will take all those files and configure a build configuration for us. So we don't have to do anything. The deployment will be started in a minute after the build process. So let's try to get back in here while the build is running, because it takes some time. Run that, and let me try to use that time to explain to you guys what is going on in terms of an OpenShift platform. So we are on OpenShift, and we have some tools to help us there to deploy our service. The first tool is the Nexus server. So this is a proxy to the internet. So instead of going there all the time, we just use this near cache to build our application. So and we have a build configuration in here, configured for source to image, meaning that we are taking all the source files and transforming that into an image. And this build configuration, I'm going to use the Nexus server. As you see in my CLI comment that I say, hey, use this Nexus server instead of going to the internet and download everything every time. And also we have the Kogito operator installed in there that creates and configures everything that we need to build our service. So this build configuration is not made by me nor manually nor anything. So the Kogito operator will do all this configuration, configure Nexus, create the build configuration for you, this OpenShift resources. And so when you send the files in here to the build config, we do start. So we build the jar file based on our sources, and it'll be the push to image service based on our sources as well. And then we deploy our Kogito workflow. That's pretty that, the process it is involved in that. And of course, the Kogito operator will manage this service as well. So you configure, we'll fix that, you deploy, and all this process of going from sources to deployment will be managed by the Kogito operator. And of course, we have the serverless platform in here, deployed by, managed by Knative. Not managed by, but it is based on the Knative project. It is basically the OpenShift platform deployed, the serverless platform deployed on OpenShift. So to manage our two services, the subtraction service and the multiplication service. So our Kogito workflow will be able to call those services when it need. Let's get back to the build. Let's see if that finished. As you see, we have a two-step build process here. And first, we build the jar files from the source. So we created all the jar files that we need to deploy to run our application, and then we package everything, all the jars into a Kogito image, and then we deploy the service. As you can see in the topology, we have the Kogito operator in here managing our conversion flow service. And let's try our service to see how it goes. So I'm basically using Crow to post to my service route in here. So this is the address of my local OpenShift cluster, and where's is my service, and using the path of my workflow. So if you remember, we have an ID that we gave to the Fahrenheit to Celsius serverless workflow, and we call that Fahrenheit to Celsius, and then we are going to use that. The Kogito runtime used that ID to generate a microservice for us. So let's call that, and the response doesn't immediately return because we are scaling up our services. So we need the subtraction service and now the multiplication service. That's pretty cool. So we call the subtraction service, we call the multiplication service. Knative will scale that for us, and then we are going to receive the reply. And if you call that again, it is immediately because I have the pods running in there. And I even can change the temperature here. So like 100 to test our use case. And yeah, we have here the Celsius product, the result of our process. And as you can see, you have the generated ID for this process. Every time you call the process, we generate a new ID with the data from the workflow. So we have the Fahrenheit value, the constants, the subtraction values, and the multiplication values as well. And another service, for instance, can take this final value here and to use that as information about the end of the service. And if we sit down and wait a little bit, you see that Knative will scale that down. So we are not using that. So let's get that down. And let's go again. Yep, pretty straightforward. So yeah, guys, that's everything that I wish to show to you guys today. Hopefully, you enjoyed the content. If you have any questions or you'd like to ask, or if you have any concerns about how to use Cogito or about how to use the serverless workflow specification, just keep in touch. You can add your comments here in the YouTube channel. Sorry, it's to be video, or send me a DM on Twitter. That is Zanini Hika. And that's it. Hope you enjoy. Please, if you like the video, just subscribe to our channel and give your like. That really help us. Okay, so bye.